Hello, welcome to the part 2 of our video lesson. This is still in relation to the lesson number 2, the addition of vectors in graphical method. Now we'll go to the cases that we will be encountering in graphical method. The first case that we will be encountering in dealing with graphical method is the parallel vector or the same vector. What if we have same vector, how to add that one? Same direction, I mean. What if we have two vectors and these vectors are in the same direction? How to add that? Letter B is antiparallel vector. What if the vectors are two vectors are in an opposite direction? What if the vector is at an angle with each other? How about if the vector is perpendicular? How to add that vector? So I will show to you step by step, case by case. Let's go first to case letter A, parallel vector. So for letter A, parallel vector, this is for letter A. Example of parallel vector, same direction, how to add. If we have vector A, that is equivalent to, let us say, 10 newtons. 10 newtons east. And we have vector B, which is, shall we say, 15 newtons. 15 newtons east. Now, to add this one, in adding vector for case number 1, this is not just a simple addition of 1 plus 1, 2 plus 2, 3 plus 3. In adding vector, we really need to show the graphical presentation of that. So to do that, let's have to set first the scale of this one, because obviously these two vectors are expressed in Newton, so we don't have a Newton unit in our ruler. That is why we will decide. Anyway, in actual activity, I will be the one to decide or to give you the scale. So don't worry for the value of scale, because I will provide that in your activity. So in this case, for example, let us say 1 cm is equals to 5 newtons. So that would be our scale. Solution, vector A, 10 newtons, converting to, in every 1 cm, we have 5 newtons. And this is 10 over 5 centimeters. That will give you 2 centimeters. Do the rest for letter B. Letter B is equals to, this is 3 centimeters. So you just copy this process for B. But I will just make it short. So 10 is 2 centimeters. 15 newtons is 3 centimeters. Now we will add that one. Now, since the direction of east is going to the right of horizontal plane, so I will just maybe graph here. This is 2 centimeters. 1, 2. This is now my vector A. And vector B is 3 centimeters. So from this is vector B, which is 3 centimeters. So this is now our vector B. Now to find the total resultant of this one, or the resultant vector of this one, we just have to go back or recall our sum of, or finding the resultant vector in our previous slide. So according to vector sum or resultant vector, always the resultant vector always drawn from the tail of the first vector to the tip of the last vector. That means, if we go back to that, tail of the first vector, this one, tail of the first vector to the tip of the last vector. That means tail of the first vector to the head of the last vector. So I will just draw there. We'll just use red. This one. And this is our, I hope you can see the red line color there. That would be our resultant vector. So the red there is the resultant vector. To find the resultant vector, you just have to measure from the tail of that first vector to the tip of that last vector and count 0, 1, 2, 3, 4, 5. So the resultant vector now is 5 centimeters. That means resultant vector is equals to A plus B. That would be equal to 2 centimeters plus 3 centimeters. That would give you 5 centimeters. So this resultant vector of 5 centimeters now will be converted into newtons. Because we will go back to the original unit of our vector. So since this is expressed in centimeter, we'll convert that back to the original unit. The resultant vector is equals to 5 centimeters times, in every 1 centimeter, we have 5 newtons. Cancel out, cancel out. 5 times 5 will give you 25 newtons over 1. That would give you 25 newtons. That means in this case, if we are asked to find the resultant vector of that, the resultant vector is simply 25. Resultant vector is equals to 25 newtons. Where is the direction? The direction is due east. So this is now the answer for that sample. This is how we add parallel vector with the same direction. You can pause the video and copy this one. Now let's go back to our presentation, PowerPoint presentation, and we will proceed to case letter B, anti-parallel or opposite direction. What if, so this is letter B, anti-parallel or opposite direction. For example, we have vector A here, which is 10 newtons, due, let us say, due east. And we have vector B here, which is due 15 newtons, due west. And we will use the same scale. 1 cm is equals to 5 newtons. Solution: convert vector A into centimeter. So 10 newtons times in every 1 cm, we have 5 newtons. Cancel newtons here. So this is 10 over 5 or 2 centimeters. Do the same for vector A. That would give you 3 centimeters. So how to add anti-parallel vector or opposite direction? Again, for vector A, that's 2 centimeter going to east. So I will plot first our vector going to east. So from 0 to 2. This is now our first vector, vector A, due east. And head to tail fashion. How about B, going to west? From the head of the first vector, I will draw the second vector. So from that head, going to 3 centimeters. So this will be the point of origin. So for vector B, this is 3 centimeters. how to find the resultant vector of that. So from the tail of the first vector, of course, from the tail of the first vector to the head of the last vector. So if that is the tail, so I will trace from this one. This is now the resultant vector. Measuring that, that will give you 1 resultant vector here is 1 centimeter. Now you will convert this one into original unit, Newton. So resultant vector is 1 cm times, in every 1 cm we have 5 newtons, cancel out. 1 times 5 will give you 5 newtons over 1. That would give you the same results, 5 newtons. Meaning to say, for letter B antiparallel with the given vectors of 10 newtons east and 15 newtons west, the resultant vector of that is 5 newtons. What is the last direction of the resultant vector? Going to west. That means this is 5 newtons west. Or you can also indicate, or you can also rewrite this one as negative 5 newtons. Negative here is representing the west direction, but the formal way of writing that is resultant vector is 5 newtons due west. So this is how we write the resultant vector of these given vectors that we have. You can pause the video and copy this one.